For as long as the Earth has been in existence, its revolution around the sun and rotation have attributed to historical weather cycles. Long-term climate patterns are a big topic of study among scientists as we hope to learn more about these mysterious global patterns. That's today's topic, weather evolution, where we've been and where we're going. Hey everyone, welcome back to Weather Legends. Another episode today. Thanks for joining us. We're going to talk a little bit about the evolution of weather, how long weather's been going on, what causes weather, where did it come from, and is it something new or something old? And we're going to talk to our weather legends today and get a little bit of insight on that. So we have got today meteorologist Joe Cioffi, meteorologist Bill Korbel. Thank you for joining us today on this interesting, insightful discussion about the evolutions and the cycles of weather. You may have heard in the previous years about global warming, climate change, and everything happening on the globe, and the polar vortex, all these terms here. But Bill, I would argue that the Earth has been doing this for a long, long time. And I think the seasons, the changes, and the actual orbit of the Earth itself around the sun maybe has a lot more to do with whether or not we've got SUVs on the road. I don't know, maybe we're putting a mission
here. Yeah. Look, we have an atmosphere on this planet. And as a result, we have weather. It's just the way it is. If there was no atmosphere, there'd be no weather. We'd be the moon. Of course, we wouldn't be here either to talk about it. So yes, as long as the Earth has had an atmosphere, we've had what we call weather, winds, precipitation, floods, that kind of thing. Now, it does vary. We have a very small snapshot of time. Carl Sagan put together something called the galactic calendar, which went back through history to the Big Bang, but this is a little closer view of things. Just look at the ups and downs of the weather over the last 4,500 years. There have been periods where it's been very, very warm. Then when volcanoes erupt, like Vesuvius in 79 AD, that impacts the weather, and it got cold for a while. That was the Grecian Empire, was cold. Then it warmed up again for the Romans. Then the Dark Ages came along, and it was cold again. Then came the folks who started traveling through the Middle Ages and on around the globe, and we were settled here in the 1600s. But these are minor changes. The Earth's weather goes back billions of years, or as Carl would say, billions of years. So we're just looking at the most recent snapshot, but even that shows tremendous changes over hundreds of years, or in some cases, thousands of years. Yeah.
So it seems like to me, Bill, that, regardless of humans interacting with the planet and anything we have going on here, nature is going to do its thing. And Joe Cioffi, tell us a little bit about the seasons. I think the seasons, and how the Earth goes around the sun and the changes that happen in those 12 months makes a big difference, big impact, and how different parts of the globe interact and what we see, right, Joe?
Oh, absolutely. And there's so many parts to this mechanism. When you look at weather maps and you put them in motion, you can kind of just sort of see the wheels and how they turn. And whenever I've tried to explain how the atmosphere works, I always described it to there used to be an old kid's toy where there were like these little gears, these plastic gears, and it was a puzzle, and you'd put the gears in place, and there was a handle on one of them. And when you turned one of the gears, all the other gears would turn at the same time. The only difference is that in weather, those gears are not static objects. They are these amorphous, constantly changing, things that these strong upper air storms, these areas of high pressure, they change in strength and size and in location, and that moves all the other gears around in all sorts of different places, and the result sometimes, in fact, a lot of times, the results are quite unexpected. They can be seeing extreme weather events in places that maybe don't normally see extreme weather events. You could probably look at this past winter, for example, and all the snow that fell along the Gulf Coast and into the Southeast. being well to the south. The gears in the atmosphere were such that they were displacing all this cold air, and it's the displacing of cold air versus warm air that causes all the volatility that we see across the world when it comes to weather. And people don't realize that hurricanes play a vital function in all of this, because that's nature's way of redistributing the heat of the summer that builds up in the lower and lower latitudes. Well, nature's got a very efficient way of moving that energy around in the form of hurricanes, which track out of the tropics and usually eventually wind up going up into the northern latitudes. There's everything that's in the world of weather has a function, and of course, the sun, the orbit of the Earth around the sun, the tilt of the Earth with relation to the sun would drive the seasons. And of course, if you think about it, if the Earth didn't have a tilt, if the axis wasn't tilted, you'd have the weather across the Earth would probably be very even for the most part.
No seasons.
I was going to ask that question. Yeah. Bill, how would that be hypothetically?
It'd be weird.
Well, first of all, it would solve a daylight saving issue.
I would just, right, because there would be 12-hour days all the time.
Right.
I would also point out, if the Earth had no tilt, we probably wouldn't be here the way we are.
Why is that?
Well, because life would have probably evolved totally differently.
Maybe.
The ecosystems would not have evolved in the same way. Where would polar bears be? They would never have evolved as a creature that learned how to navigate the polar region of the Arctic region, because there's no polar bears in Antarctica. But these animals that adapted to their environments, well, there wouldn't be much to adapt to if the weather is temperate and the weather is pretty much the same. You wouldn't have extremes. You probably would not have tropical storms, or if you do, they would be just
the average daily temperature would be the same.
Yes,
year round. Up here up in Long Island, maybe the average temperature would be what, 70, 65, somewhere there.
All year round.
The tropics would be. Would the heat from the tropics would spread further north, and then you'd have this sort of distribution of all that heat in a much more even keeled way.
Yeah, when I talk about weather, people, very, very quickly, how it starts is the atmosphere just tries to even out the heat around the planet. It's constantly moving the warm air near the equator northward, the cold air near the pole southward. The Earth is rotating, which puts a spin, which causes storm systems in high pressure areas, and the oceans have a huge influence too. The thing is, it is incredibly complicated.
Oh, yeah.
We know why things happen, but we can't nail down the details when it comes to forecasts. Simple thing like a summer sea breeze here or a spring sea breeze, if you live near the shore, like Long Island South Shore, that's a minor part of the equation, but affects us. That takes place on a much larger scale globally.
Yeah, and I tell you what, to Joe's point, besides the tilt of the axis, and the seasonal changes that do occur with the direct sunlight and indirect sunlight, you've also got elevation. The Earth is not completely flat everywhere. So, Bill, how does elevation play a role too, right? It does, no matter what.
Just think of the variability of the planet, okay? 70% of the planet is covered by water, first of all, the oceans. Lands vary from barren desert areas to lush forests to green areas to Rockies to mountains. Each of these impacts the weather to some degree. The oceans have the biggest impact, but take elevation, as Rich mentioned. As you go up, what happens? The air gets colder at about 5 degrees per 1,000 feet, 5 degrees Fahrenheit per every 1,000 feet on average. That's how much colder it gets. So if you're at the top of Mount Everest, there's snow on the ground in the middle of summer because you're at 28,000 feet and it's in the 30s. Now that is globally. So if you live at a higher elevation, it's naturally a little colder, except when local winds blow. For instance, there was a time out in West and South Dakota near the Black Hills where, believe it or not, with the Black Hills just to the west of the town there, the temperature rose something like 60 or 70 degrees in a few minutes just with a wind shift. So mountains, elevation, seas play a huge role in what kind of weather we get.
Yeah.
Just one other point I want to throw into when we're talking about the Earth's axis and the dynamism of the Earth and its atmosphere. We've gone through cycles over tens of thousands and hundreds of thousands of years where places that are deserts now used to be fertile land and paradises, and then they turned the whatever changes that happened over the long term. And when I'm talking of long term, I'm talking over tens of thousands of years.
Yeah.
Those so far, the Sahara Desert was once a big forest, and something happened that changed all that. The movement of we also have the movement. The continents are not these things that just sit there.
Continental drift.
And when you look at Africa, for example, at one point was actually split in half. There was water that went. There was water between half we had one side and another side, and then gradually over a million years or whatever it was, that gap closed, and that changed that made a wholesale change in the climate across Africa, and all of this has downstream effects. The people don't realize, for example, that the Saharan dust is vital to the Amazon rainforest, because that dust carries nutrients across the Atlantic that settles in South America and feeds and fertilizes and created the Amazon rainforest. If that dust went away, the Amazon rainforest would go away.
Okay, here that thing was called Pangea.
Yes. I was going to mention
I'm just
that.
looking at it. 175 million years ago.
Yes.
Africa, South America, the United States, all connected. Antarctica, there was one big blob of land, and slowly it drifted apart to what we see here. So if you get a time lapse of the last, say, billion years, you'd see this breaking apart. And I actually have seen time lapses. I can't remember where they showed how everything spread apart around the globe. But we're here for just a segment. I mentioned Carl Sagan's cosmic calendar. He starts at January 1st. At the Big Bang, and we go through the Milky Way forms, the sun forms, the Earth forms. The last 10 seconds before midnight is where humans have been on the planet, relative to the global time frame.
And we've done a great job, haven't we?
Well, we're doing a job of messing it up at times, that's for sure. Well, I want to show you something. See this stuff?
Hold on.
It looks like calculus to me.
This is my notebook from NYU when I was a meteorology student. I'll be honest. I hope it's not backwards. I have no idea what all this stuff was I wrote. Not the vaguest idea. Because I wanted practical meteorology, short-term forecasting, not a reason.
So, well, they teach you that. Yeah, they teach you that, Bill, because calculus, the physics, the fluid dynamics about what the atmosphere is. And this is the whole point to the general public,
gives
how
you
complicated and how it's just doing a weather forecast. When, you guys, we have the modern technology. We should be hitting it all the time and getting it right. You guys are always wrong. But like Joe mentioned in the beginning, the complexity of what we're dealing with, the fluid dynamics, the calculus, the changes, and the errors, too, for that matter. I mean, and look at the time, Bill. I mean, millennia, I guess you use that word, going back, we go back to this chart here where, the changes that have happened without even humans interacting on the planet that nature just decided to do. I mean, was there any measurements back then during the eruptions, during, BC, during those years, 3,000-4,000 BC? I mean, how did we measure? How did we know? We didn't have the science yet to understand it. We're just saying that the physics has been there forever, and the evolution of weather as we know it has been going on with all these factors, like we mentioned, the tilt, the seasons, the elevation, the water, Pangea, how the continents drifted. I mean, Joe, what else? I mean, God, we can probably roll off some other stuff that goes on. I think the physics of what we learned with the with gravity for all things, right? Doesn't gravity play a role in how the air and how how things happen?
Sure.
Right?
Yeah,
right,
the
Joe?
air is more dense down low near the earth than it is up high. A quick thing, when we're talking about all this, we have to realize that we may now, for the first time, have a chance to influence the atmosphere in certain ways. We are putting more carbon dioxide into the atmosphere, and that may be warming it up. The only thing that's worrisome is, could we reach a point where you get a runaway greenhouse effect?
See, and I'm gonna jump in here, Bill, on that question, because I'm a firm believer of this of this idea, and I hope I'm right, because otherwise, your the theory that you're proposing here with a runaway greenhouse effect would be a problem.
Yes, you're right.
But I am always and have always been amazed how nature can take a stretched rubber band and it just snaps right back. And I have put out there this idea in my mind that maybe there's a tipping point where you get so warm that you set off a chain of events that reverses it all.
Now it gets too cold.
And then it goes in the other direction. And, if you bring up the time thing you had, Rich, when I looked at this, and I had seen this before, but I hadn't seen it in a long time. And I noticed in the area at 1991, when the eruption of Mount Pinatubo, you have this big global temperature spike down in what has been, a fairly consistent uptrend that started somewhere coming out of that little ice age. But my point is that nature seems to find a way to repair itself, no matter how much we do to it. I remember seeing on PBS they did a special on the nuclear plant in the Ukraine that melted down. I forget now, what was the name of it? Chernobyl. Okay, and they've gone back. It was a nature show, and I think it was David Attenborough that voiced it. But they went back now after all these years, and they have found that trees have come back, wildlife has come back, where there were some of the old buildings. Some of the old buildings that are there, and in the cracks that were in the concrete, you had plants that found their way and took root. And my point is that nature seems to find, no matter what we do, whatever we do, that we get to a place where nature is going to snap the rubber band back in the other direction. So I'm kind of like I'm in this tipping. Get to the tipping point and then snap it back.
You just said something like I heard in Jurassic Park, the movie. Nature finds a way.
Yeah, and nature does.
We're here. Nature does what it's going to do. We have to learn to live with it.